Let's look at a problem that says find the second derivative. There's nothing in particular that's new here. We've found a second derivative before. Maybe this is uglier than what we've taken the second derivative of before. But still, I'm going to find the first derivative of x to the 1/2 is 1/2 x to the -1/2. Then I could say the derivative of x, but the derivative of x is just 1, so I don't have to. That's the derivative of the first term. The second term is going to take the product rule, because e to the x is not just a constant, natural log of x is not just a constant. So I need the first factor times the derivative of the second is 1 over x, plus the second factor times the derivative of the first. The derivative of e to the x is still e to the x. Now, that won't clean up very much. It's easy to take the second derivative of that. That, if I write it as a single fraction, let me go ahead and do that. I can write that middle term as just e to the x over x, and it's going to take the quotient rule. This is going to take the product rule again. So that's the first derivative. And then the second derivative, use the power rule. -1/2 times 1/2 is -1/4. X to the -1/2 minus 1 is -3/2. That's the derivative of the first term. Second term, by the quotient rule, start with the denominator times the derivative of the numerator is just itself, minus the numerator times the derivative of the denominator, but the derivative of the denominator is just 1. And that's over the denominator squared. That's the derivative of the second term. The derivative of the first term, or excuse me, the third term, that's what I differentiated right here and got that. So I'm just going to get that again. By the product rule, I'd have e to the x times 1 over x plus e to the x natural log of x. And if I can clean that up, I will. I think that probably the first term will be written as -1 over 4x to the 3/2. Second term, I could factor out an e to the x from the numerator. You know what? I could factor out an e to the x from all three of those terms, but I don't know that that's going to help me. If I just factor an e to the x out of the numerator of this term, that leaves me x minus 1. Second term, or excuse me, third term, I can write that as e to the x over x. Fourth term, not much I can do to it. The only thing that I can see that even may be beneficial, and I promise I'm not going to give you something this hard on the test. You don't have time to spend this much time on one problem. But it would be pretty easy to combine those two terms by multiplying this by x over x to get a common denominator. That gives me a little bit simpler expression, not a whole lot. But if I factor an x, if I factor an e to the x out of those two numerators when I combine them, I'll have an x minus 1 left from the first fraction and an x from the second fraction. X minus 1 plus x is 2x minus 1. And that's how the answer is written in the back of the book. It is not pretty no matter what you do. And third time I've said this, but there's not going to be one that hard on the test. It's good practice, though. All right, let's see, after 114, the directions change. Number 116 says find the derivative of the function at the given point. So I have the fifth root of something. I'm going to go ahead and write that as 3x cubed plus 4x to the 1/5. That's just ugly to the 1/5. And the derivative of ugly to the 1/5 is 1/5 same old ugly to the negative 4/5. But then I also have to have the derivative of the ugly, which would be 9x squared plus 4. If I were leaving this as my answer, I'd probably take one more step and put that ugly to the 4/5 in the denominator. But since we're supposed to evaluate that expression at the point 2, 2 that was given to me, I just need to substitute this 2 in place of all the x's. That would be 3 times 2 cubed. 2 cubed is 8. 3 times 8 is 24. Plus 4 times 2 is 8. Times 9 times 2 squared. That's 36. Plus 4. Very lucky for me, I can take 1/5 of 40 is 8, and I can take the fifth root of 32. The 1/5 times 40 is 8, and this expression means the fifth root of 32 to the negative 4. Fifth root of 32 is 2, and 2 to the negative 4 is 1 over 2 to the positive 4, or 1 over 16. That whole expression, this derivative evaluated at 2, 2, equals a half. And if I had to find the slope of the tangent line, which I don't have to on this problem, but if I did, then the slope of the tangent line is a half. I could use that slope and this point and find the equation of the tangent line. All right. We have time for just one other very important thing that we only got to talk about very briefly last Friday, and that was our last two derivative formulas. One was, well, let's see, they're on the handout. You have to have these memorized. You'll have 2 points like these on the test, or 2 problems worth about 6 points each. So make sure you have those memorized. The derivative of a to the x is same old a to the x, but then multiplied by the natural log of a. And the derivative of log base a of x, just not like natural log, it's 1 over x, but then you have to take the natural log of the base in the denominator. So let's see if we can do a few examples using those two new rules. For example, 131 to 146, I'll use those two rules. Let's do 138 by the product rule. Now, I could have started with an easy one, but you probably didn't need an example of an easy one. So this one is kind of ugly. It's ugly looking. It may not be hard to differentiate. One thing to make sure you understand, that negative alpha over 2, that's the same as negative 1/2 times alpha. So when we get to the point of having to take the derivative of the exponent, it's just going to be negative 1/2. I don't know if you need to take a whole step to make that distinction or not, but if you do, if it helps you, write it down. Then the derivative by the product rule is the first factor times the derivative of the second. The first factor is 5 to the negative 1/2 alpha. Derivative of sine ugly is cosine same old ugly times the derivative of the ugly. And that's just half of the product rule. That was the first factor times the derivative of the second. Add to that the second factor times the derivative of the first. The derivative of e to the ugly is e to the same old ugly. Similarly, the derivative of a to the ugly is a to the same old ugly times the derivative of the ugly. But then also, according to this formula, not only do I have a to the same old ugly, or a to the same old ugly times the derivative of the ugly, I also need the natural log of the base as a factor. So here I would need the natural log of 5 as a factor. Now that's the second factor times the fairly ugly derivative of the second. As far as cleaning that up, make sure you don't multiply the 5 times the 2, because the 5 has this exponent. Let's see. Both terms have a 5 to the negative 1/2 alpha in common. That's the only thing they have in common. And I don't like to leave fractional coefficients, so here's what I'm going to do. I'm going to factor a 1/2 times 5 to the negative 1/2 alpha out of both terms. I have factored out this expression. I need to keep up with the cosine.
Your conference is scheduled to end in 2 minutes.
And if I factor a 1/2 out of a 2, that will leave me the coefficient 4. If I multiply that, I get back the first term that I started with. Second term, I'm factoring out a 1/2, but I still have the negative. I factored out the 5 to the negative 1/2 alpha. All that's left is the sine of 2 alpha. And so I believe the simplest way I can write that is 4 cosine 2 alpha minus sine 2 alpha over 2 times 5 to the positive alpha over 2, or positive 1/2 alpha. I could bring that to the denominator because of its negative exponent.